Welcome friends, let's take a look at this function and see when a series doesn't exist. So f of x is equal to, say, 1 over x. Let's think about this for 1 second. So if you try to evaluate the function at 0, you have 1 over 0, but this is just d and e. It doesn't exist. Okay, so here's a graph. Let's graph this for reinforcement. So f of x equals 1 over x, graph it. So it looks like this. Here, this is x equals 0. There's a vertical asymptote. So it looks as though you should not be able to construct a series representation of the function here. How do you represent, for example, this, right? Like infinity up there, you see? As x goes towards 0, the values of the function blow up towards infinity. But nevertheless, let's pretend that we can. So let's compute f prime of x. That's just the derivative with respect to x of x to the negative first. But that's just negative 1 x raised to the negative 1 minus 1 by the power rule. So it's then just negative 1 over x to the second. That's the first derivative. But again, notice that f prime of 0, this is negative 1 over 0 squared. But again, this is d and e. It again doesn't exist. So look, f prime looks like this. Negative 1 over x squared. It's just a function. When you graph it, it just gives you a graph. It's just a green graph here. The point is the green graph, which is f prime. Again, it does not exist at x equals 0, you see? Why is that relevant? Well, it's relevant because when you look at the shape of an expansion, what do you have? Like f of x is roughly something like the following, okay? You have a sub 0. So let's say it this way, okay? Like f of x sub 0. So where the point you're expanding, f of x sub 0. And then you have usually something like the first derivative, so f prime at x sub 0. And let's say everything is 0 in our case, so like make this just 0, okay? Like this. So f of 0, but already stop for a second. F of 0 for f of x equals 1 over x. This already, like this part right here, this already does not exist. You see this? Right here. This doesn't exist. There's no value assigned to it right here. It's d and e already, okay? Then you have something like f prime at 0 times x to the first. And usually you set this over like 1 factorial. But again, stop for a second. This quantity, f prime at 0, already that doesn't exist right here. And that's this part right here. That doesn't exist. Correct? So that means f prime at 0 evaluated here doesn't exist. Then you go on to the next one. The next one is something like f double prime at 0, x to the second, and then you divide this by 2 factorial, but stop for a second, and then plus dot 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 to continue the pattern. Notice something. F double prime at x, well, that's just the derivative of f prime of x, the first derivative, which is then just the derivative with respect to x of negative x to the negative second. So just taking this, writing it this way, then it's negative 1 times negative 2, and then x raised to the negative second minus 1 at the power rule. But that's just going to give you 2 over x to the third. But guess what? Again, this quantity right here at 0, so f double prime of 0, this is 2 over 0 cubed, which is what? D and E. It doesn't exist. So you see, in other words, like this doesn't exist, f double prime of 0 doesn't exist, so this series makes no sense for the reasons that I'm showing you here. That's why, in other words, you can't represent 1 over x at x equals 0 with a series. It's obviously not like that depending on the value of x, always. Now let's expand at x equals 1, just to see the difference clearly, hopefully. So f of 1 using the same function is 1 over 1, right here, which is just equal to 1. No problem. You just get you put a number in, you get a number out. You see? F of 1. Let's do that into f prime, which is negative 1 over, and then this would be 1 squared, which is negative 1 over 1, which is negative 1. Again, no problem of any kind. So this is f prime right here. Just be clear on that. Okay, and this is f double prime of 1. Notice that the function exists at 1, the first derivative exists at 1, the second derivative is 2 over 1 cubed. That's just 2 that also exists at 1, right? A number goes in and a number comes out, which is very different from trying to do f double prime at 0 because you're dividing by 0, there's no value you can assign. So now, putting this together, we can get an approximation that looks like this, roughly speaking. So f of x is roughly equal to the value of the function at 1 plus the first derivative at 1, officially speaking, kind of like 1 factorial this way, okay? Right, and then you have to be careful because you're expanding at x equals 1, you have to type like x minus 1 here. So be careful, okay? Right, and then it's to the first. If you want it to be very formal, let me move this over a little bit like this. Right, and then here, plus f double prime at 1, divided by 2 factorial. And then you have to multiply by, hold on, well, that's the issue, right? Fitting it all. So this would be plus f double prime at 1 over 2 factorial times x minus 1 squared. And then you kind of continue this pattern, basically, okay? Just continue that pattern with some ellipses going in that direction. So now, let's actually do this. You're going to have f of x is roughly, we know f of 1 is 1, plus f prime at 1, well, we know that's negative 1. So you're going to put minus 1 and then x minus 1. Now stop for a second and just look at what you have on the screen. When x is 1, you have 1 minus 1, which is 0. Negative 1 times 0 is 0, so 1 is left over. And that's the way it's supposed to be because the function, the black curve at 1, has the value 1. Okay, and then, well, f double prime is 2, so this would be plus 2 over 2 factorial, which is like 2 over 2, which is 1. So you're going to have x minus 1 squared, okay, and then dot, 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 that kind of situation here. All right, so this is the value of the function, basically. That is like the tangent line right here. This whole thing is the tangent line. And then lastly, like this part right here, that adds curvature so that you match the shape of the graph. So let me just do this. Let me remove the other ones that we did there previously. This one, let's remove this one. I'm going to enter these one piece at a time, so hopefully you'll understand better what things are. So the only thing left on the screen is 1 over x. So now input just the 1 minus the x minus 1, the first two terms. That's the tangent line. Now add to that this term right here with the square. So put them all together, so you're going to have 1 minus x minus 1 and then plus x minus 1 squared. Look at the difference, right? I'm just adding one term, the x minus 1 squared term. And you get the red graph, which as you can see hugs the original function a bit better. So again, we should be focusing over here, correct? Like in this region, you see? So the black graph is 1 over x, the tangent line is the green graph, and the red graph, which matches the curvature of the black graph better, is this, all of this, 1 minus 1 x minus 1 plus 1 minus x minus 1 squared and so on. But the point is that the function 1 over x can be represented with a series at 1. Whereas, as you can see, at 0, right, this right here is not defined. The first derivative is not defined there at 0. The second derivative right here is not defined at 0. So you can't represent it using a series like this, okay? I'll leave it at that. So leave a like,